When we envision the Arctic, pristine icy landscapes and crystal-clear waters often come to mind. However, this remote wilderness harbors a hidden crisis, one of the world's highest concentrations of microplastic pollution. This startling revelation raises critical questions about how these tiny plastic particles are reaching such isolated regions and what can be done to address this growing environmental threat. Microplastics, defined as plastic particles smaller than 5 millimeters in diameter, have become ubiquitous in our oceans. While the issue of plastic pollution is well known, the extent of microplastic contamination in the Arctic has shocked researchers and environmentalists alike. Studies have revealed alarming concentrations of these particles in Arctic waters, ice, and even deep-sea sediments, painting a grim picture of pollution in one of Earth's most remote ecosystems. The scale of the problem. Recent research has uncovered the true extent of microplastic pollution in the Arctic. A 2020 study found more than 1,000 microplastic pieces per cubic meter in the Arctic water column. Even more concerning, several studies have detected extremely high concentrations of microplastics trapped in Arctic sea ice, with one study reporting up to 12 million particles per cubic meter in certain areas. The problem isn't confined to surface waters and ice. Microplastics have been discovered at depths of up to 1,000 meters below the ocean surface, with particularly high concentrations found in deep-sea sediments. This vertical distribution of microplastics throughout the water column and into the seabed suggests that the Arctic Ocean is becoming a major sink for global plastic pollution. Sources and pathways of Arctic microplastics. The presence of diverse types of microplastics in the Arctic indicates that this pollution is not simply the result of local activities or the breakdown of larger plastic waste in northern waters. Instead, it points to the long-distance transport of microplastics from various global sources. Researchers have identified several pathways by which these particles reach the Arctic. Ocean currents. Both Pacific and Atlantic currents play a significant role in transporting microplastics to the Arctic. Currents moving through the Bering Sea bring pollution from the Pacific, while Atlantic currents carry North American and European waste northward. River systems. Rivers, particularly those flowing from Siberia, transport microplastics through populated areas before discharging into the Arctic Ocean. Given that approximately 10% of the world's river discharge ends up in the Arctic, this represents a substantial influx of urban and industrial pollution. Sea ice movement. Floating ice rafts can trap and transport microplastics over long distances as they move through Arctic waters. Atmospheric deposition. Some microplastics may reach the Arctic through precipitation, having been carried by air currents. Local sources. While not the primary contributor, local activities such as fishing and poor waste management in nearby communities also add to the microplastic burden in Arctic waters. The diversity of these pathways demonstrates the global nature of the problem, with plastics from distant urban centers and industries finding their way to one of the planet's most remote regions. Impact on Arctic ecosystems. The accumulation of microplastics in the Arctic poses significant threats to the region's delicate ecosystems. These tiny particles have been found in a wide range of Arctic organisms, from seabirds and fish to marine worms. While the full extent of health impacts on these creatures is not yet fully understood, the presence of microplastics in their bodies is cause for serious concern. Microplastics can cause physical harm to marine life through ingestion or entanglement. Additionally, these particles often carry harmful chemicals, either from their manufacturing process or absorbed from the surrounding water. As Arctic animals consume microplastics, they may also be ingesting these toxic substances, potentially leading to long-term health effects and disruptions to the food chain. The Arctic's role as a global sink for microplastics also raises concerns about the potential release of trapped pollutants as sea ice melts due to climate change. This could lead to a sudden influx of microplastics into Arctic waters, exacerbating the problem and potentially spreading the pollution to new areas. Challenges in addressing Arctic microplastic pollution. Tackling microplastic pollution in the Arctic presents unique challenges due to the region's remoteness and the global nature of the problem. Unlike localized pollution issues, microplastic contamination in the Arctic cannot be solved through regional efforts alone. The tiny size of these particles makes them difficult to detect and remove from the environment, especially in harsh Arctic conditions. Furthermore, the long-distance transport of microplastics means that pollution originating from far-flung locations contributes to the Arctic's contamination. This global dimension necessitates international cooperation and coordinated efforts to address the issue effectively. Proposed solutions and future directions. Despite the challenges, researchers and policymakers have proposed several strategies to combat microplastic pollution in the Arctic. Improved global waste management. Enhancing waste management practices worldwide, particularly in coastal areas and along major rivers, can help reduce the amount of plastic entering waterways that eventually lead to the Arctic. Stricter regulations on Arctic activities. Implementing and enforcing stricter rules on fishing and other industrial activities in Arctic waters can help minimize local sources of plastic pollution. Development of biodegradable materials. Encouraging the use of biodegradable alternatives, such as biodegradable fishing nets, can reduce the input of persistent plastics into Arctic ecosystems. Enhanced monitoring and research. Continued scientific studies are crucial to better understand the sources, pathways, and impacts of microplastics in the Arctic, informing more effective mitigation strategies. International cooperation. Given the transboundary nature of microplastic pollution, international agreements and collaborative efforts are essential to address the issue comprehensively. Public awareness and education. Raising awareness about the global impact of plastic use can encourage individuals and communities to reduce their plastic consumption and improve recycling practices. Technological innovation. Developing new technologies for plastic removal from oceans and waterways, as well as for tracking the movement of microplastics, can aid in cleanup efforts and pollution prevention. The road ahead. Addressing microplastic pollution in the Arctic requires a multifaceted approach that combines local action with global initiatives. While the challenge is significant, there is growing recognition of the need to protect this unique and vulnerable ecosystem from the insidious threat of microplastics. As research continues to unveil the extent and impacts of Arctic microplastic pollution, it becomes increasingly clear that our actions, even in distant urban centers, have far-reaching consequences for the planet's most remote regions. The Arctic's microplastic crisis serves as a stark reminder of the interconnectedness of global ecosystems and the urgent need for sustainable practices in our use and disposal of plastics. By taking decisive action now through improved waste management, innovative technologies, and international cooperation, we can work towards reducing the flow of microplastics into our oceans and preserving the Arctic's fragile environment for future generations. The journey to a plastic-free Arctic may be long, but it is a crucial step in safeguarding one of Earth's last great wildernesses and the global ecosystems that depend on its health. As we move forward, continued research, public engagement, and policy action will be essential in turning the tide against microplastic pollution. The Arctic's hidden crisis of microplastic contamination is not just a remote problem, but a global challenge that requires our immediate and sustained attention. Through collective effort and innovation, we can aspire to restore the Arctic to the pristine wilderness it once was, ensuring that future generations can experience its beauty and ecological importance free from the scourge of plastic pollution.